introduced the multi-port network at the last time. We introduced the Y parameter, short circuit admittance parameter, J parameter, the hybrid parameter, and the T parameter, transmission parameter. YZHT is very similar to the two-port multi-port, very similar to the two-port network. And we also introduced the connection of the multi-port network. It's similar to the two-port network also. Today we will introduce the active multi-port network. This active means the network contains the independent source.
Excuse me, Laoshi.
Oh, sorry.
We can't see
Can
your
you-
screen, sir.
Oh, sorry. Okay. Wait for a while. Okay. Can you see it now?
Yes. Thank you.
Okay. Okay. I will repeat. We have introduced the multi-port network. We introduced YZHT parameter is similar to the two-port network, YZHT parameter. And we also introduced the connection of the multi-port network. We have four kinds of connection: the parallel, serial, hybrid, and the cascade. Cascade is also similar to the two-port network. And today we will introduce the active multi-port network. The active means the network contains the independent source. The network active in here means the source inside. Treat all the port voltage as stimulus and all the current as response. We can divide the total response to two groups: the port voltage source and the inner source. Treat the port voltage means we use U to express I. We treat the port voltage as source. And we use superposition. The port voltage source work alone. We assume all inner source doesn't work. That means although this network contains the independent source, but we assume there's no source inside at first. No source means the voltage source, we can treat it as a short connect. The current source, we treat it as an open circuit. And first, we assume the inner source not work, so we got the I sharp. This is the outside U work alone. Treat it as a passive network. This voltage. We use voltage to express current, so we treat the voltage as source. U1, U2 as source. Then we got the I sharp 1, I sharp 2, and the first. And then we assume the inner source work alone. The inner source means the outside has no source. No source outside, so the outside should be short connect all the outside. All port voltage source not work. This I sharp 2 means only the inner source work alone. So the total current, we can use superposition to express the total current is I sharp plus I sharp 2 equal to YSC multiple U. This U means port voltage plus ISC. This ISC means short circuit. Short circuit the outside port. Short circuit this position. Short circuit the outside port, and then calculate the current. This is the meaning of the ISC. So the I equal to YSU plus ISC. This function, very similar to the Norton's law. But pay attention, the Norton's law only for the one-port network. But this function very similar. This I is a vector, maybe I1, I2, and this YSC is a matrix. This U is also vector. This ISC is a matrix. So we call this function as a generalized notation. We can also get the U equal to GOCI plus UOC. That means we use current to express voltage, and at first we assume the inside source not work, only the outside work, and then assume the outside this not work, means open, only the inside work. So we use the UOC, open circuit, to express. So this function similar to the Newton's law. Newton's law. Actually, this is a generalized Newton's law for multi-port network. We can also use hybrid to express. That means some port current and some port voltage to express the U1 and I2. So for the I1 port, we use the U1OC express. U2 port use I2SC to express. The relation between the UOC and ISC for this function and this function, the ISC and the UOC relation is very easy to calculate by yourself. It's very easy. The I minus ISC equal to YSC U, and the inverse YSC, so it will be GOC multiple. So the U equal to GOCI minus GOCISC. So this this part is a UOC. This is a UOC. This is a UOC and IC relation. The connection of the active multi-port network. If the multi-port network contains source inside, when we parallel N1, N2, so we add the use more details. We just introduce an example. Find this figure. Active. The active means the source inside. 3 port. Port 1, port 2, port 3, 3 port network G parameter. So the total function of this set will be U1, U2, U3 equal to G. This G parameter will be 3 multiple 3 and I1, I2, I3 and plus UOC1, UOC2, UOC3. So this is G parameter, and we will also need to calculate the UOC also. So this function will be the total function for this 3-port network. At first, this 3-port network, we can treat this 3-port network. We can treat it was the serial connect of the network A of the B and C serial connect. This point is here. Is this point, and for this point is from this position connect to this position here. So we can treat this port 1. Sorry, this point is here. This point is here. So the port 1. This port 1 sharp, 1 sharp, and 2 sharp. This point 2, this point 2 sharp, 2 sharp. This point 3, and this is 3 sharp, 3 sharp here, 3 sharp, 3. This 3 sharp. So we treat this figure, this 3-port network as the serial connection of these two networks. By this method, we can make this network, and this network simple. So we can calculate the port 1, this port and this port independently. At first, calculate this network. This is the active network. At first, we assume it's passive. Assume it's passive means there's no source inside. No source, so this point will be short connect. This will be open. This short, this open. It will be like this. Pay attention. This short, this open, so this will be data connection. 12, 12, 12. This data connection. And 4, 6 is here. 4, 6. This 8, it is here. And for this data connection, we transfer it to the Y connection easily. 12, 12, 12. So every component will be 1 over 3 of the data connection. So for this network, this 3-port passive network, it will be easy to find the Z parameter. Z11, Z12. Sorry. As for the calculate of this network, I will add one page. To calculate the Z parameter, according to the definition, we assume the port 2, the port 3, I2, I3 is 0. At first, add the I1 only. Add I1 here. This I1, and then calculate the U1, U2, and the U3. So this only I1. So the U1 will equal be 4, 4, 4. It will be 12 I1, and the U2 will equal be this U2. I1 flow in this loop. So the U2 will be minus 4 I1. And the U3 will be this 4 ohm resist voltage. So the U3 will equal to the 4 I1. So for the Z parameter, the first column is 12 minus 4, and then assume I1 is 0, I3 is 0, add I2 only. Add I2 only. This I2 here. This U1. So the U2 will equal to only this loop. 8, 4, 4. So it will be 16 I2. And the U1 will equal to this resist voltage, but inverse. Sorry, this U1 will equal to minus 4 I2, and the U3 will equal to U3 will be this 4 ohm resist voltage, 4 I2. So the column 2 will be minus 4 16, 4. And then step 3. Assume I1, 0, I2, 0. And then add I3 only. Add I3 only. Is I3. So the U3 equal to this loop. It will be 14 I3, and the U1 will equal to U1 will be only this 4 ohm resistance, 4 I3, and the U2 will equal to U2 will be this 4 ohm resist voltage will be 4 I3 also. So the last column will be 4, and 14. So this will be the G parameter of this network.
Minus.
And we come from
minus 9.
Which position?
The
Do you mean this minus? This minus?
third column.
Which position? Okay.
Repeat it.
For this minus because U2 is here. When we add the I1, when we add the I1, this loop, and the U2 is here. U2 is this positive, negative. But the current flow from the up to down. The U2 is down, up, so it's minus. And this minus also the same. So this G parameter, GOC parameter, for this passive 3-port passive network. So the first step to calculate the GOC, and we know for this network is active. U equal to GOCI plus the UOC. We need to calculate the UOC also. Now we calculate the UOC. This is GOC for this network. For the UOC, at first, UOC means we assume the inner source work alone. The outside, there's no source. When calculate the G parameter, no source means open circuit, open. So this open. So only this inside two source. For this network, when we calculate the U1OC, and we assume there are two sources inside. We assume the two sources work alone. So the voltage source work at first. This is 12. There's a resistor here, but no usage. So this is 3. So in this loop, this will be 1. This will be 1, and this will be 1. This is 3 volt. So the U1 for this part, U1 sharp will be -1, because this will be 1. So this is -1, and this -1. And for the U3, is this position positive, negative? It will be +1, positive. So assume the voltage source work alone at first, and then assume the current source work alone. The current source work alone. So the voltage source is 0. Voltage source 0 means short connect, and the current source is current source. This 0.4 ampere. So there will be 12 ohm and this 24 ohm parallel. 12 and 24 parallel. And the total parallel resist will be 12 multiple 24. This branch and this branch, this is the total resist. So the total voltage from this point to this point to this point is the total voltage, the total resistance marked the current source. This point to this point is just U1. It's just U1. For the UOC2, this point to this point, it will be the inverse of this resistance. So it will be 1/2. That means half of the this voltage, the total voltage. This is the total voltage. This resistor is half of the total voltage, and there's a minus here, minus here. For the U3, the U3 will be this 12 resist voltage, so it's also be half, but there's no negative, it's positive. So this is the total voltage, total open source voltage of the 3-port network. So for this network, the total function is U1, U2, U3 equal to 12 minus 4, minus 4, 16, 4, 4, 4, 14. I1, I2, I3, and plus 2.2 minus 2.6 and 2.6. So this for the total, this total 3-port active network. 3-port active network is this function. For the next part, for this part, it has a source here, so it's also active. But we can write the U and I relation directly because this network is very simple. For the U1, is I1 here, so it's only 6I1, 12, so it's 6 I1. So U1 is 6I1. For the U2 is this position. For the U2 will be a little complicated. This I2, and I2 plus this current source, IX here, IX is here. This IX equal to 1/2 I1. This I2, this IX, so it will be total I2 plus 1/2 I1 mod 4.5. So this total current, this position current, and the mod the 12, this resist will be the total U2. So it will be this function. It will be a little difficult. For this port, this I3, this 1, so it will be I3 plus 1 mod 24. I3 plus 1 mod 24. So it will be this function. So for this network, it will be simple to write the total function. It will be U1, U2, U3 equal to I1, I2, I3. This will be 6, 0, 0. This will be 27, 12, 0. And for this function will be 0, 0, 24, and plus 0, 0, 24. And then we can find this network. This Z parameter is not symmetry. Attention, this position is not equal, so it's not symmetry. Because this network contains a dependent source. So it's not symmetry. But for this network, it's symmetry. This will be symmetry. Symmetry because there's no dependent source inside, no dependent source. So for the network, no dependent source. Dependent source, the Z or Y parameter will be symmetry. If there are dependent source inside, it will be always be not symmetry. Always not symmetry. So this is this network, the ZOC parameter. So the total network ZOC is the total ZB, ZC added together. And total UOC is UB, UC added together because they are serial connected. They are serial connected. So for the total network is this network. Is this network. The total network Z parameter. So this is the Z parameter for this active 3-port network. So everybody of you should know how to calculate this kind of network. You should know how to calculate this kind of network. Active multi-port network Y and Z parameter. YZ parameter. And for this YZ parameter, it also includes the Z parameter includes the UOC. If asked you to calculate the Y parameter, it will include the ISC. So you can try to learn how to calculate this network Y parameter. Please calculate yourself how to calculate the Y parameter of this network. Equal sec of the multi-port network. For this active network, active multi-port network equal sec. If we use I to express U, this is the H parameter. This is Z parameter. For this is the active, and this is the U parameter. U express I, the Y parameter. When we use U to express I, we can treat it as this network will equal to this passive network and parallel connect the current source outside. If you use Z to express, we can treat it as a passive network serial connect the voltage source. If we use the H parameter to express, we can treat some of the port serial connect, some of the port parallel connect. This function, this figure is a generalized Norton's law. For the common Norton's law, there will be for any one port network, any one port network, it will equal to a current source, parallel connect a resistor. This is the common Norton's law. This is a generalized Norton's law for multi-port. This is the general Thevenin's law. For common Thevenin's law, it's a network serial connect a voltage source, a resist serial connect a voltage source. So this is one port. This is multi-port. And for this network, it's generalized power transform. What does this mean? Power transform. So that means from the right figure to the left figure, we transform some of the port to current source. But some of the port still left. This I2 still left. So we call this as a power transform. Power transform means from the voltage source What is source? Two counter source. What is source? Two counter source. So this is a general circuit of the multi-port active network. For the active network, we can equal them to the passive network. A serial or parallel independent source outside. So this is equal. What the equal means? Equal means the active equal to passive plus source outside. Okay, for the start to net, we should add a page here. Start to net. This means in the undergraduate course, we have learned the Y to Z connection. This Y connection, and this data connection. We call this data connection, Y connection to data connection. And for this part, we'll learn about the star to net. Star to net. What star means? Star means in the Y connection, we add another more, this Y1, Y2, Y3, maybe we add Y4 or I5 here, I5 here. We call this kind of the connection as star connection. So star connection is a generalized of the Y connection. For the star connection, for example, for the 4 port, 1, 2, 3, 4. The corresponding connection is we call net connection. Why call net connection? This 1, 2, 3, 4. The 1 will connect to 4, and 3 will connect to 4, and 2 will connect to the 4 also. So we call this net connection. Because it seems like a net, So the net connection is generalized of the data connection, general data connection. For the Y2 data, the Y connection will have 3 components. For data connection, it's also 3 components. But for the star connection, for the 4-point star connection, we have 4 components here. But in the net connection, 1, 2, 3, 4, 5, 6 components. So they're not equal. For the n node star connection, in the net connection, the components will be n minus 1 over 2. What is this express from the n nodes, we choose any 2 nodes, C and 2. From n nodes, choose any 2 nodes. So it's n minus 1 over 2. So for this n nodes, these 4 nodes, these 3 nodes, we can all use this function. For the 3 nodes, 3 multiplied 2 over 2 is 3. For the 4 nodes, 4 multiplied 3 over 2 is 6. For the 5, for example, 5 nodes, so it will be 5 multiplied 4 over 2, it will be 10. So we can find from this kind of connection, only Y2 data, they are equal. 3, 3, they are equal. For the 4 nodes, is 4 to 6. For the 5 nodes, is 4, 5 to 10. For the 6 nodes, there will be 6, will be 15. So they are not equal. Only this kind is equal. This follows the star connection to net connection. This definition, what star and net connection. At first, we'll introduce how to transfer from star to net, but from the net to star, it's impossible. It's impossible. I will introduce later. For the star to net connection, it comes from the Lawson's theorem. Assume n two terminal element connect star connection terminal. We use four nodes to express four nodes. It's kind of radiation connect. We also call as star connect. It is equal to a sect with n terminal CN2 element net connection. So this is a net connection, four nodes net connection. So there will be six components. This is four components. If we try to make them equal means the current and the watch relation equal. Current watch relation equal. Assume the current and the watch equal. They're equal. So we study the net connection at first. Assume IN equal to YSIUN. GN equal to YAIUN. AUN node voltage. UN is node voltage. For the star net connection, star I1 is here. I1 is here. I1 is Y1 multiple. This is U1. This is U0. U1 minus U0 minus 0. This is I1. I2, this position I2. U2 minus U0 multiple by 2. I3, this is I3. This is I4. And we know I1 plus I2, I3, I4 is equal to 0. This is KCL. So the Y1, U1 plus Y2, U2 plus Y3, U3 plus Y4, U4. Add these four together, 0. Add these four together, 0. And then we can use the U1, I1, U1, Y1, U2, Y2, U3, Y3, U4, Y4 to express the U0. Try to express U0. Express U0. This YY means add all the Y together. And then place this UO to this position. And to this position. And to this position. Plus UO2 inside. We can found every current I1, I2, I3, I4, every current will equal to this expression. How this expression come from? We will add one page. I1, use I1 to express. I1 is here. I1, Y1 minus the Y1, U1 minus UO equal to Y1, U1 minus Y1 plus Y4, and just YK, UK, Y1, U1 plus Y2, U2 plus Y3, U3 plus Y4, U4. So for this U1, we express as U1 Y1 plus U1 Y2 plus U1 Y3 plus U1 Y4 over Y1 plus Y2 plus Y3 plus Y4 minus Y1 plus Y4 and Y1 U1 plus Y2 U2 plus y3 u3 plus y4 u4. And the first part will be deleted. For the left part, it will be y1 plus y4. So u1 y2 minus u2 y2. So y2 u1 minus u2 plus y3 u1 minus u3 plus y4 u1 minus u4 or minus u4. So it will be y1 plus y4 y1 mark the y k from 1 to n, k from 2 to 4, y1 yk u1 minus uk, and we can press the y1 inside, press y1 inside. It will be like this y1. So this I1 is pressed. This I1 is pressed. Just this expression, Okay, let's have a rest. 10 minutes. 10 minutes rest.